Okay. Here, I want to show you one more, show you the data of the Lab7. Okay. I want to talk a little bit about the data. Okay, let me share my screen. Okay. Yeah. Look at the table I provide to you. Okay. So the first table is for the friction loss versus size. So you have 4 sizes, right? 4 size of pipes, 1 inch, 3/4, ½ inch, and 3/8. But for each experiment, okay. By the way, here set the flow rates, right? We set the flow rate. We only change one in each experiment, which each category of experiment only change one parameter. For example, the first one we change the diameter only, right? So we keep the flow rate the same, 9 GPM. We keep the length 48. Okay, we don't change. We only change the pipe size. Okay, so we have pressure drop. This is the pressure value, pressure differences. Okay, between 2 pressure gauges. Okay, so there's 10 readings here. Okay, again, you already did some fluid experiment. You know, the fluid measurement is difficult to get very accurate data. So the problem is the flow is kind of like sometimes it's fully unsteady, transient. It changes all the time. Just like this. If you do experiment, you will see on the computer screen, the pressure varies. The pressure fluctuates, okay? Fluctuates all the time. It changes all the time. Every second you look at it, the data changes. So what we do is we record it with the same interval, a 1 second interval. We record the data, pressure readings. So total 10 seconds for 10 readings, okay? So hopefully we can get the average value here. You need to do the average, right? You get the average value and we get some. You can also, from a series of data, not only you can get average, but also you can get the standard deviation to show the how it fluctuates about the mean value. What is the fluctuation magnitude, right? This is the standard deviation. So for each data, we get 10 samples, okay? So please calculate the average data. Use the average data for the calculation, average pressure drop for your calculation in the report, but also calculate the standard deviation for each data set. Okay, same thing here for the second part of the experiment. You have 2 lenses, the first 24, the second 24, so total 48. You can calculate, right? Total 48 actually is already measured in the previous ones, since it's a ½ inch, 9 GPM, same. So this third set of data is total 48-inch pressure drop. Here, we measure the first 24-inch and measure the second 24-inch. It should be the same, first 24, second 24, but it turned out to be slightly different between the front and the back. Okay, so I guess when you do the 24, you can average these two, front 24 and the back 24. Okay, first of all, for each one, you average the 10 samples. Okay, then you average of the front and the back. That's the characteristic pressure drop for the 24-inch. Okay, so and also standard deviation. Okay, same thing for the third part of experiment for the four different. I think in the video I mentioned 5 or 6 different flow rates. Actually, the data sheet will only have 4 different flow rates. That's fine. Okay, 4 different flow rates. We choose the ½ inch pipe, also 48-inch length. Okay, we change the flow rate. So you will have 4 data points on your plots. Okay, for the measured loss versus flow rate. Okay, 4 data points for the measured and 4 data points for the calculated. Okay, so in this report, in the discussion part, you can also discuss a little bit about the standard procedure for doing flow measurement. You have to do samples, right? Do samples, get average, and find the deviation, and you can determine the uncertainty of your result, right? So based on the how big it deviates from the mean value, something like that. So add some discussion. I like you to play some discussion on the measurement procedure. Okay. Okay, that's the data sheet.